Hey guys, so in this video we'll be continuing with the C# tutorials. So we'll be going over, so to start we'll learn about initializing variables. So in C#, a variable must be assigned a value before it can be used. So I think we've already done this, so we can probably skip that. So if you can also declare multiple variables with one statement. So the way to do that is we can just go, so string, so if we say string str, str1, str2, str3, so you can do that. So basically okay, so you can declare 3 strings here, or 4 strings. They're still different variables. You can just do them on one line. So this is the same thing to it's the same thing as this. So if we just delete that or comment it out for a sec. So it's the same thing as doing this, public str. Public string str. Public string. Why am I using public? I'm using public because in C#, it automatically makes your variables private. So I don't want it to be. You should make them private though, so maybe I'll just do that. Why should you make them private? Well, you should make them private because it helps save you from bugs and potential hacks, I guess, like your software, because other files can access it. Basically, you can get like file snooping. Basically, you probably want to just keep them private, so nothing can really get into the file. So here you could have so basically Java doesn't make them automatically private. I believe it keeps everything public unless you specify. But here we'll just say private string str, then so this is the same thing as what we did before. It's the same thing as this. So that's the same thing as right above here. So there are 4 different variables. So we could have also gone like this. We could have said private string str points to we'll just go with some kind of fruits or something. So we have str points to plum, and we have str1 points to apricot, str2 points to orange, and str3 points to tossed salad. Alright, so let's so pretty much we have different variables here. So this is the same thing here as so if we take the comments out, let's just comment this out for a sec. Sorry, I was trying not to laugh actually because that was kind of a joke, but that was probably not a very appropriate joke, but I was just trying to be funny, so hopefully no one gets upset about that. So basically, actually probably more than half the people won't even get it, because it's, if you don't really know English, then you won't get it. Most people might not even understand what the joke was, but that's okay. So if we have, I probably couldn't do that in a university class if I was a professor though, because that'd be probably, well, I guess I didn't really do anything wrong, but just trying to make you guys laugh. So we have, alright, so if we have, basically, we could just go here with plum. Then it's the same thing as str1, sorry. It's the same thing as, basically it's the exact same thing as just initializing them. Like that. So basically you can do everything in one line, or you can do them like this. Sometimes it's convenient if the types are the same. So you may just want to quickly define 3 ints or 3 strings, but not declare them. If you're declaring them, it may, it's up to you, whatever you feel comfortable with. It's exactly the same thing. So we'll just move on from that. These are fields, by the way. They're global variables. So you put global variable. I don't think they're called global variables in C#. They're called fields. So a field just means that everything can in the class can access it, even if it's private. So if it's private, other methods can still access it. But if it's private, other classes can't access it. If it's public, then other classes and namespaces can access it. Basically, even if it's private, other methods, so this is a constructor, but if we have other event handler methods, for example, they can all access any private variable. So if it's different from a local variable, so if we have a local variable here, let's go with public void get str, get str. So we just have a private, actually no, sorry, so we could say str3 points to something, I don't know, blueberries. So in this case, you can access it, anything, you can access any fields, pretty much. So we'll talk about this stuff later on in more detail. Yeah, so that's pretty much it. So we'll just continue on. So now we'll talk about numeric data types and variables. So basically, so C# has, I believe there might only be 3 types of number types. So basically we have int, double, and decimal. So let's just take these away. So if we have, let's just delete these strings. So if we have, let's just go with int val1. So it's automatically doing that. You could turn it off probably, so maybe I'll just go with private. So private double val2. Private decimal val3. So basically an int, if you don't know what it is, it's a whole number. So we could go, okay, so in this case, then we could say, we could set val1 points to 5. Actually, I don't think it really wants me to set those up there. Okay, let's go with here. Try that here. Could I have done that? Why didn't it work like that for some reason? Doesn't like me initializing, declaring and initializing variables without, so just kind of in the class area, top of the class. I think it wants me to actually do them in the constructor, so what did I do there? We'll talk about this later on, but you can initialize, so this val, we declared it, but it didn't really want me, so you can initialize it here to 5, so val1 points to 5. But if I just declare val1 here, so let me just throw my shades on here. Alright, so I threw my shades on because it helps me, it reduces the pressure in your eye from staring at the screen for too long. Because obviously if you're coding it, you have to stare at the screen. Okay, so we could go with, so we go val1 points to 5 here, it doesn't like that. Wants me to use, yeah, it doesn't like that at all, I think. Did something there automatically, val1 points to 5. Why is it making it capital? It doesn't like that, so how can you fix that? I guess it doesn't really like, I don't think it, let's just see if it does that to strings too, so string str1 points. Okay, let's just go str points to melons. No, it doesn't like that. Why doesn't it like that? I'm assuming it doesn't like that because it doesn't want you doing all these kind of operations in the like in the top of the class area. What it wants you to do, I believe, is use the constructor. So this is a constructor here. So constructor sets up variables, objects, parameters. So you can use that to. So what can we do here? We can go with. We can take this out. So we can go with. So here, if we go with val1 points to 5. So you can initialize it here in the constructor, seems to like that. So then we could go str points to juicy melons. Alright, so basically that's pretty much it, how to use a constructor. We'll be going over this, what the constructor is, more so later on. Let's just stick with these variables, kind of getting used to declaring and initializing. So we're going to focus on the number type here, the number types. So the C# language provides several primitive data types. So most of the types have special purposes. We haven't talked about decimal yet, we'll talk about that in a sec. Okay, so let's talk about int. So an int data type can hold whole numbers only, so you can hold 5 here. But so you can hold a whole number which is like 1, 2, 3, 4, 5, so it's not a real number, I guess they call. I think of it as a floating point number, but that might just be from C. So we have 5.2 is a real number. It doesn't like that because you can't have decimals, so an int can't be a decimal. So it only works with 5.0 or whatever number you want, 2.0, 2.8, whatever, 2.3, whatever you want. Some large number, 0.4. No, that's not going to work. So it won't, sorry, apologize. It can't be a decimal number. So it can be 2, 3, a whole number like that. It can't be 0.4, so sorry for the confusion. And int can't have a decimal. You can't have a decimal. It can be like 10, 1. So these are whole numbers, right? But it can't be 10.1 or 10.222. That's a floating point number or a real number. You can't store a decimal number in an int. So let's just go with 2. So we have val1 points at 2. Then we can go with double val. So we have a double there. Val2 is a double. Points at 2.2. That'll work. 2.222. A double can also store whole numbers as well. 2.0, whatever you want. Okay. So an int variable cannot hold numbers with a fractional part. So 22.2 or negative 4.5 won't work. The int data type is the primary data type for storing integers, so an int is an integer. An int variable uses 32 bits of memory and can hold an integer number in the range of I think it's negative 2,147,483,648 through the negative of that. Actually, sorry. Negative 2,147,483,648 through 2,147,483. Sorry, 2,147,483,647. So it's a pretty large number. You don't really have to know those. I'll probably just skip that, but it's it can't store any numbers larger than that. So if you want to store more, you can use a decimal. You can also use a double, might be larger. I think it is larger. So you can go with a decimal. Probably just safest bet is to go with a decimal if you really need to. But I think a double might do it. So a variable of the double data type can hold real numbers such as 3.5 or negative 82.92 or 3.0, so we just talked about that. So a number that is stored in a double variable is rounded to 15 digits of precision. So we use variables of the double data type to store any number that might have a fractional part. So the double data type is useful for storing very large or very small numbers. So a double variable uses 64 bits of memory. It is stored in a format that programmers call double precision floating point notation. Double is very common. Most of these are very common. String, int, double. So variables of the double data type can hold numbers in the range of positive to negative 5.0 times 10 to the power of 200 and 2000, sorry, 10 to the power of 2,324. So negative or positive 5.0 times 10 to the power of 2,324 to negative or positive 1.7 times 10 to the power of 308. So the notation's kind of confusing, but you can just, if you're really interested in that, just check it out. So if we have the last type, which is decimal, this is a new type just specific to C#. So a variable of the decimal data type can hold real numbers with greater precision than the double data type. A number that is stored in a decimal variable is rounded to 28 digits of precision. Because decimal variables store real numbers with a great deal of precision, so you can use them in they're good for financial apps. So we can use the decimal type. I'm wondering if decimal types are in the Ninja Trader platform, because the Ninja Trader API uses C#, I think. But I use MQL5, so I just created a video on. I'm starting a tutorial on that if you're interested. But it's based on C++, which I don't think it has a decimal type. But all the C languages have very similar. They're all similar. They're based on each other. So in this, basically, when we do our examples, we'll use the decimal type to store basically any currency, apps, or anything. Basically amounts of money. So in memory, a decimal variable uses 128 bits of memory, so it's the biggest numerical type. Primitive numerical data type. It is stored in a format that programmers call decimal notation. Variables of the decimal data type can hold numbers in the range of negative positive 1.0 times 10 to the power of 228 to 7.9 times 10 to the power of 28. That's the number stuff's kind of confusing. Just use the biggest one if you really think you'll need that much numbers that large. Alright, so let's just continue on here. Alright, so so we have basically numeric literals. So this is a little confusing. Usually they say string literal, but I guess in programming terms you could have a numeric literal or a string literal. They're the same thing, so we'll just talk about this. At the time when you're writing a program's code, you may want to store a specific value in a variable. You can assign that value as a literal to the variable. So this is just an initialization, basically. So a numeric literal is a number that is written in a program's code, for example. So a numeric literal is a number that is written in a program's code, for example, the following. So the following that we'll do in a sec declares an int variable named whatever, just some int val, and initializes it with the value whatever 10. So here we could have let's just go with int var points to 40. Oh yeah, it made it private. Okay, so then we have double var2 points to whatever. These are numeric literals. So the number 40 is a numeric literal, and the number 100.2 is also a numerical literal. So this number here is the literal right here. So we'll just go with, that's pretty much it. That's pretty much most of it. Just seeing what else I can show you guys for this tutorial. So when you write a numerical or numeric literal in code, the numeric literal is assigned a data type. That's all fine, we could skip all that, just the same stuff that we just did. Oh yeah, we didn't do any decimals. Okay, so we have, let's go with private. Whoops, sorry, that's not a type. Private decimal there points to, actually don't really like that word decimal. So we got numval, so here we'll go with low juicy melons, we'll go with, so numval points to so we can go with like some large number point. So you can have decimals as well. So you have to throw an M on the end. So I'm not sure why, that's just the reason. That's the way they did it. I think it stands for money. So we'll go with basically, so if we just do that, yeah, so it wants it, I believe it needs the M on there. Has to have the M on. So let's just talk about that. So let me just try to find some info on this here. So, actually, sorry. So yeah. So when you append the letter M, so I think it can be capital or lowercase. The M can be capital or lowercase. Excuse me. So when you append the letter M to a numeric literal, it is treated as a decimal. That is referred to as a decimal literal. So it has a different name. Okay, whoops, I think there's a little bit of theory that's a little bit different. So numeric literal can be different things. So it can be an int. It's a generalization, but you can be more specific. So for example, val, so int val1, so here val1 points at 2 is a integer literal. So if we go, okay, so double val2, so val2 is a double literal, and the decimal val3 is a decimal literal. So it's basically they're just more specific, if you know what I mean. str3 doesn't know what str3 is here. What happened with that? Okay, so we had, that's alright, so let's just, actually, what happened here? We have, oh, whoops, sorry, private string, str3. Okay, there we go. Sorry, I've been coding too much Python lately, so I'm forgetting the types. So okay, so let's, I think that's pretty much it. So a decimal can store just a whole number as well. We'll talk about casting. We can cast the types around to change the types and all that. So we'll probably just end it there. So thanks for watching, guys. If you guys like the video, you can like and subscribe to the channel for more programming and investing tutorials. In the next tutorial for C#, we'll be talking about basically some of the errors that can happen with numbers using casts to convert the types. Then we'll go on some math calculations. Then we'll do, what else we do? We'll talk about some, yeah, so that's pretty much it, math calculations. Mixing data types with math calculations. Let's see what else we have here. And then back to numbers with GUIs. Converting the types with the GUIs. That'll take us to for the next bit. So thanks for watching, guys. Hopefully I'll see you guys in the next one. Take care.